Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Welcome to my channel, Budi M.Sc. We are going to discuss about duality and dual simplex algorithm. It is the chapter 6, and it is the part 1. For the next part 2, we are going to make the video. Okay, duality is a concept of linear programming that is very important to learn both in mathematical and practical theory. Actually, it is very important for the company to decide any kind of the changing, for example, in resources and something like that. There is some benefits, and two of them is to assist in testing or checking the truth of the optimal value obtained by the simplex method. And the second is the discussion of post-optimal analysis is also very important to know in depth. And it is, I will describe or reveal about the dual simplex algorithm. Even this topic we are going to discuss in another videos. The dual simplex, it is how to find the solution if there is not feasible in the condition of the optimal solution. Okay, duality. The linear programming consists of two forms. There are primal and dual. The primal form is the initial form of a linear programming problem. On the other hand, the dual is duplicate from the primal. The concept of primal and dual can be interpreted as opposite to, meaning that if there is a primal of a linear programming problem, there will be an opposing form that is a dual. The solution between primal and dual will be interrelated. That means if you find the primal model, you can automatically you can determine the dual model from the primal, because it is there is related between primal and dual. If a primal problem is solved using the simplex method, then the optimal solution can be used to determine the dual problem. And the last, it can be concluded that primal problem will have dual partner and vice versa. In other words, the optimum solution for dual will be provide the optimum solution for the primal and vice versa. It is about the duality. Now, we are going to discuss about the interpretation of the dual problem. Okay? Interpreting the dual model of linear programming, it is necessary to first understand. You have to understand about the primal. There are 5 of important things to understand. Okay? The first, you have to when you want to change the primal to dual problem or to dual model, you have to change the objective function. It is not purpose, maybe it is appropriate you just the objective function. The first is changing the objective function. The second one is changing the meaning of each variable used. For example, if the primal is referred to x1 and x2, what the meaning about this one? So you have to determine the meaning for the dual, what the x and what it was. Maybe you can change to the y1 and y2, something like that. Okay, the third is changing it is in the constraint. For example, if the constraint is less than or equals to, so you can change it to the greater than or equals to, and vice versa. And the fourth, the change in the coefficient of limitation metric. Actually, the coefficient will be the coefficient in the dual is the transpose of the coefficient of limit metric in the primal. And the last, we have to know how to change the changing in the right hand side in primal and dual. Okay, it is the Panglong-Jaya trade business problem. If you want to see this problem, the original problem, you can see or open this link in the above. Okay, it is the model, the primal model of the Panglong-Jaya trade business. Maximize Z like this, and it is the constraint. There is two constraint, and it is non-negative constraint. Okay, you have to remember this one. In the primal model, X1 is refers to the number of door should be produce maybe. And X2 is represents the number of window production. Okay, and we have to change about this one in the dual model. Okay, three important points that should be considered in interpreting primal problem into the dual. For include this. For the first is interpretation of objective function. Okay. If you want to change or construct some problem into dual form, you have to interpret the objective function. Based on the primal model above, the objective function is to maximize production profit. Conversely, of course, the objective function will be changed to minimization of cost. Okay, so if the primal is maximization, so in the dual should be minimization. Okay. The second one is interpretation of variables. Before we construct the dual model, we have to interpret about the variables. Variables in the dual problem are constructed by relating them to the primal constraints. So it is the primal constraint. Okay, we can see that the first constraint is about time limit for manufacturing, even it is windows and doors per week, and the second constraint is time limit for painting. Okay, time limit for painting per week. So it is as a variable in the dual. Okay, like this. The variable y1, it is associated with the first primal constraint. Okay, it is the primal constraint. This one. Y2 with the second primal constraint. Yeah? Y2 refers to this one. Okay. Furthermore, Y1 represents the per hour free charge to the manufacturing of process. It is Y1 refers to this one. However, for Y2, it is referred to the second constraint. Okay. Therefore, the dual objective function determined like this: minimize W equal 100 Y1 plus 180 Y2. Why? Because it is the cost of the manufacturing, and 180 is the for the painting. Okay, it is for the painting. All right. All right. The third is interpretation of dual limit or constraint. Okay. The first constraint on the dual is constructed by considering the cost of production. Okay. The cost of production, or manufacturing and painting cost, door. Okay, it is for door. It is manufacturing and painting cost for door. This is obtained by relating it and considering the variable contained in the first column, of course, right? In the first column, that is xy, x1. Okay. There is to produce one door unit takes 1 hour. It is 1 hour in the manufacturing process and 3 hours in the for painting process. Okay. So the cost required to produce its door is like this: 1 by 1 plus 3 y2. Okay. It is we find from this one. 1 hour in the manufacturing and 3 for painting process. So for the first constraint in dual like this. Then in order for the seller to get a profit of it is a profit at least like this. The profit is 400,000 rupees. Of course, in the first constraint should be greater than or equals to, because the profit should be at least or more than like this, 400 and 1,000. So the first constraint is like this: y1 plus 3y2 greater than or equals to 400,000 rupees. How to construct the second constraint? It is the step is same with the first step. It is same step. Okay. So the second constraint in the dual form or the dual model, by considering the cost of production or manufacturing and painting windows. Okay, the first is manufacturing and cost for door. However, for the second constraint is manufacturing and painting windows, something like that. So we know that the relating variable contained in the second column of the Primal model, right? So it is related to the x2. However, to determine the first constraint is related to x1 and it is related to x2. Consequently, the second constraint become like this. Okay, become like this. And the last is the non-negative constraint. Actually, in the Primal it is x1 in x2, and for the dual is y1 and y2 should be greater than or equals to 0. All right. So we can conclude that for the dual model like this, it is the objective function. It is, of course, it is minimization of the production cost. Okay, that means to minimize the loss or the loss. Okay. How about the constraint? It is the first constraint and it's the second constraint. We're finding the slide previously. It is the non-negative constraint. So it is the interpretation of the y1 and it is y2. So we can conclude that to determine the dual form of Primal, then Primal variable xi for I equal 1, 2 until n will be related to the nth limit of the dual. Okay, you can see about this conclusion. All right, it is the general model of Primal and dual problems. It is the Primal and it is the dual. You can see it is the objective function of the Primal is sigma j to the n equal 1 c j x j. It is like this. However, for the dual, it is maximization. In the dual should be minimization. Okay. And the objective function like this. Actually, we use it is w here, and the objective function like that, like this. You know, b is the right hand side or solution in the Primal. However, in the dual, to be become coefficient of the objective function y I, right? How about the constraint? It is the constraint in the Primal. Okay. However, it is the constraint for the dual. You can see it is IGXG, it is IJA, means it is here, AJYJ. Okay? Alright. To become much clearer about the concept, I am going to reveal about this concept. Okay, two model of linear programming problem like this. There is symmetric and asymmetric. Okay, for the first, all linear programming is called to be symmetric. Symmetric, right? It is symmetric. It is symmetric. It is okay. Is fulfilling the following condition. The symmetric if the model is symmetric if the all variable is positive. Okay, the variable positive should be like this, and maximization the function objective function. Then all the constraint is less than or equals to like this. If the objective function is maximization, this should be the constraint is less than or equals to. Otherwise, if the problem is minimization, should be the constraint greater than or equals to. So, if like this, so the model is symmetric. To determine the duality problem, then it is necessary to refer to its primal form, wherein if the objective function in primal is maximization, then its duality model should be minimization. Okay. Furthermore, if the constraint in primal is less than or equals to, of course, in the dual should be greater than or equals to. All right. It is the general model of the primal and dual. It is the objective function of the primal, and it is the constraint. So we can see to the changing. For example, this one, maximization CIXY X1. However, in the dual is minimization. You can see this one. Okay. And here is C, but in dual is not C, it is B. Well, from this B, from this one, B1. However, B2 is from the solution in the second constraint, and so on. Is BM from the solution in the M constraint, like that. Okay. Now, how about the constraint? The constraint, it is the primal. For the first is primal. It is A11. It is A12, right? It is A1N. How about the dual? Is A11, A21. It is AM1. So we can conclude that the coefficient in the first constraint in the primal is transpose this one, right? So coefficient of the first constraint in the primal is transposed in the column of the dual. We can see this one, A21, A22, and A2N. It is the transpose one, of course, to this one. Okay, 2, 1, A22, A2N. So it is the transpose. Transpose this one, right? Okay. So we can conclude that the coefficient, the constraint of the primal, the coefficient, the constraint of the dual is transpose of the coefficient in the from the primal. Okay. Of course, we can write the notation like this, ZC. Okay. However, it is B transpose. It is be transposed from this one. Okay. However, the constraint coefficient constraint is this one, A transpose. Okay. How about this one? It is the C transpose from this one. It is C1. It is from the coefficient in the objective function. C2 from the however Cn is from the coefficient xn, something like that. So it is C transpose and y greater than or equals to. Okay, maybe it is very clear. Alright, it is the general rules of the primal dual relationship. The primal, if the objective function are maximization, so in the dual should be minimization. If the sign is less than or equals to, so in the dual should be greater than or equals to. And it is vice versa, okay? Vice versa, it is vice versa, okay? It is also vice versa. Non-negative constraint like this, y greater than or equals to, of course, in the dual is y greater than or equals to. How about the objective coefficient CZ? It is right-hand side of the constraint, okay? In the dual, right-hand side. However, right-hand side of the primal BI, it is objective coefficient in the dual. Okay. Okay, matters. If you have any question, you can deliver your question to our channel. It is the primal dual pair, okay? If the primal is minimization or if the dual is minimization W, of course, in the primal should be maximization, and it is vice versa. It is vice versa, okay? It is for the dual, however, it is for the primal, something like that. It is the objective function for the primal, however, it is should be and however it is the object the right hand side in the primal in the dual, okay? Okay, it is the conclusion. The conclusion is the constraint is formed by pairing, because the dual and primal is in pair. It will primal variable. Therefore, the number of dual delimiter is equal to number of primal variable. Of course, right? And the second one is the primal objective row coefficient serve as right hand side the dual. Okay, I have described this one the previous slide. The dual objective coefficient are constructed by the primal right hand side. Okay, if the objective function on the primal problem is maximization, then the dual should be changed in the minimization, and vice versa. Okay, if the inequality of the constraint is less than or equals to in the primal, should be greater than or equals to in the dual, and vice versa. The jth column in the primal coefficient the same as the jth row in the dual, of course, right? This, in other words, the element in the dual are transposed, like I have revealed in the previous slide. It is the transpose of primal element. If the primal problem has an infinite solution, then the dual will have invisible solution. If the dual has invisible solution, then primal also will have an invisible solution, of course. Okay, how about to convert or to construct a dual model if the model or the problem is asymmetric? Modeling the dual form or primal form that asymmetric can be executed by determining the primal form and equation or, in the standard form. Okay, I mean, if you want to convert the primal asymmetric primal problem, for the first we have to convert the model to the standard form, like that. For example, like this, it is the primal, right? It is the primal, it is asymmetric problem. So if you want to construct this model or to convert this model to dual, the first step you have to construct this one to the standard form. It is standard form or equation form. It is the standard form. Because it is greater than or equals to, you have to add surplus variable and artificial variable, and it is less than or equals to, it is slack variable. Okay, it is y1 and y2. Okay, dual form. So the dual form like this: maximization w 6 y 1 10 y 2. However, the constraint is this one, right? It is coefficient is 1, coefficient is 2. It is y1 plus 2 y2. It is 2 and negative 4. It is 2 and negative 4. Okay. However, it is from the coefficient of the objective function x1, and it is from the x2. How to determine the non-negative constraint? It is from this one, negative s1, so it is negative y. It is from this one, r1, it is from to be y2, and s2, it is from y1. Okay, so we can conclude from these three constraints, it is y1 greater than or equals to 0, y2 is less than or equals to 0. Okay, I think it is not so difficult, it's easy. And the properties of primal dual asymmetric form like this, it is for the asymmetric. You can see to this slide. Thank you very much for your attention. If you have any question, you can send your question to our channel Budi Haloman M.Sc. Thank you. Assalamualaikum warahmatullahi wabarakatuh.